We begin chapter 2. The first we begin with number systems. So here we have a few terminologies regarding the storage. The first one is bit. Bit is a short for binary digits. Binary digits. So that's a bit. So it can store only one or zero, two states. You can store one of the two states. You can store, so the two states could be represented by on and off or high or low and the like. In abstraction form we use 0 and 1. So bit is a storage where you can store 0 or 1. That is a binary number or bit. So byte is 8 bits there. The byte is called the smallest possible addressable unit. In most modern computers, you have a main memory. In main memory, storage is organized by byte, which is 8 bits there. So for a group of 8 bits, a byte has a unique address. Here's address 100, 101, and so on. So that's why we called it smallest possible addressable unit there. And then the word is any contiguous group of bytes depending on the hardware of the computer, especially CPU architecture. One of the old CPU, the word size is 2 bytes, 16 bits. Mostly now is 64 bits is the word. So word does not have a specific size. Depending on the system, it's different. And then another terminology which we rarely use in these days anymore is called the nibble. Nibble is a 4 bits. So in a byte we have 8 bits. So we have two nibbles there. So high order nibble or low order nibble is there. Then we come to a numbering system. So numbering system here is how to count. So in our daily life, a decimal number is the one we use. In decimal here means 10. So what do we mean by 10 is we use 10 different symbols for counting purpose. Those symbols are ordered as follows: 0, 1, 2, up to 9. So we have 10 different symbols. So using those symbols we count. So here this means nothing, but if I have a 1, then we use the first symbol, a second symbol after 0, and then if I have one more, we use the next symbol, one more, next symbol, and so on. And then we use this symbol if we have up to 9 things there. Then if you have one more now, since we have used up all available symbols, what you do is we introduce another position or another digit. So here we introduce another position. There we put this guy and 0. So that's a meaning. Since we have used all 10 symbols for the first position, we now introduce a second position. So we keep doing for counting purpose, and then after 1 9, and then we have a 2 0 and so on, and then all the way to 99. Then we have used all the symbols for 2 positions, so we now introduce one more position. So that's a positional numbering system for decimal. So similarly, we can represent the integer counting value for any radix, any base. Here radix or base means how many symbols you want to use. So suppose we use 3 symbols, then we call 3 base or 3 radix. For counting purpose, we use only 3 different symbols. Say we have those 3 symbols in order we use, then it's a 3 radix number. So in 3 radix number counting is as follows: 0, nothing, 1, 2. We have used all available symbols, so we introduce another position. And then 2, 0, 2, 1, 2, 2. So we have used all symbols in the second position, so we introduce another position, and so on. So this is a 3 radix. In computing system, the most interesting one in our study is a binary, which is a 2 radix. As we understand, in 2 radix binary number, we have use only 2 symbols, 0 and 1. So positional numbering system, suppose we have a radix 10, then each position has that weight. So here, first position, second position, and third position, the 7 in this position has a weight of 10 to the 0th power, so which means 1. And then next position has a 10 to the first power, so 4 means 4 times 10, and next one 10 to the second power. So given radix system 10, each position has a weight and then with some power depending on which position you have. Similarly, for a fraction part, now you have a negative power. So the first position after the decimal point is 10 to the negative first power, and then negative second power. So that's the meaning of a positional numbering system. So we can apply this idea for any radix system. So if we use a radix 2 binary system, then this digit 1 means 1 times weight of this position is base is 2 since it's a binary, and 0th power. And second one is this weight, next one this weight, and so on. Then if we convert this to decimal number, this is how to convert to decimal number. So converting from other radix system to decimal number is by applying the weight of each position and then sum up. That's the corresponding decimal number.